Take a look at a differentiating technique called the chain rule. It's used for composite functions, which are functions within other functions. So just as an example here, we're going to calculate y prime, the derivative of y, also known as dy dx, for this function. Y equals the quantity 5x plus 1, all raised to the 6th power. So just take note that this is a composite function. We have this little function, 5x plus 1, inside of another function which is being raised to the 6th power. So we're going to use, to look at the chain rule, we're going to use another mathematical technique called U substitution. And my previous video gives a little algebraic example about that. So feel free to take a look at that if you'd like to get an idea of what U substitution is about. But what we're going to do here, the first thing you have to agree upon is this little statement here. Dy dx, also known as y prime dy dx, one and the same, just different notations. So is equal to dy over du times du over dx. So first of all, just think of these as quantities, things that are being multiplied and divided here. And you can see these du's, because du over du is 1, will cancel. And so we can agree that dy dx is the same as, after these cancel, dy dx. Okay, so we're going to use U substitution to temporarily make this equation look easier to work with. We're going to let U equal this contained function, the function that's inside of the other function. So we're going to let U equal 5x plus 1. If we do that, we can rewrite this equation, and it's going to say y equals, think of our substitution now, u to the 6th power. So I'm going to write that out. Y equals u to the 6th power. Okay, so now we're going to just differentiate this equation with respect to u. That's this little quantity right here, how that looks. So we know that the derivative of u to the 6th power, use our power rule here, is 6u to the 5th power. And over here, we need to calculate what du dx is. That's the derivative of u with respect to x. So that's going to look like this. And once again, use our power and constant rule here. Du dx is 5. So if dy dx is equal to the product of these two quantities here, dy du, which we have, and du dx, which we have here, then based on that, we can say dy dx is 6u to the 5th times du dx, 5. Okay? Or y prime dy dx, same thing. Let's just simplify this a little bit and say dy dx is, I'm going to bring this 5 out front here, 5 times 6. Remember, u is a temporary substitution method. Okay, so instead of writing u to the 5th here, what is u equal to? It says right here that u is the same as 5x plus 1. Okay, so our final answer, dy dx, or y prime, is 30 times the quantity 5x plus 1 to the 5th power. Okay. Let's take a look at one more example here. This one will go a little faster. Feel free to pause it and rewind it if you need to, if I'm going too fast. So again, we see a function here. We see an inner function, which is 2x squared minus 3x, and we see an outer function. We're going to let u equal that contained function. Therefore, if I rewrite this, I can, since that is the same as u, I can write that u to the 4th power. I'm going to then find dy du using the power rule, and the same thing goes, I'm going to also find du dx using the power rule here. So then based on this little statement here, we're going to substitute in dy du, which we found to be 4u cubed, and du dx, which is 4x minus 3. And the last thing we're going to do is make sure our answer reflects everything has to be in terms of x, because that's what the original problem was, in terms of x. So I'm going to finish by saying dy dx is 4 times the quantity, what's u? U is right here. 2x squared minus 3x to the third power times 4x minus 3. And you don't have to go crazy simplifying. This is a great answer to leave.